Hi everyone, this is lesson 1-6, function operations and compositions of functions. Our learning target today will be for students to be able to perform operations with functions. Operations with functions, there's 4 operations: sum, difference, product, and quotient. You should be familiar with all of these words. The sum of two functions is adding the two functions together. The difference would be subtracting the two functions from one another. Product would be to multiply the two functions together. And quotient would be to divide one function by another. In the definition of operations with functions, it states that we need to let f and g be two functions with intersecting domains. Okay, so f and g are going to have intersecting domains, and then for all x values in the intersection, the sum, product, difference, and quotient of f and g are new functions defined as follows. Okay, if we're going to write out the sum of a function, you might see it referred to in two different ways. You have f plus g of x is equal to f of x plus g of x. You have f minus g of x is equal to f of x minus g of x. F times g of x is equal to f of x times g of x. And f divided by g of x equals f of x divided by g of x. And this is stating that g of x cannot equal 0 because, of course, we know that we can never divide by 0, so g of x would not be able to equal 0 in this example, or in this definition. So one thing they mention is that f and g have to be two functions with intersecting domains. What this means is that their domains have to overlap. So if you looked at the domain of f and g separately, they would have to have some sort of x values in common, or share some x values within their domain. Okay, so when you're looking at f, the domain of f, and the domain of g separately, there would be x values that f and g have in common. Another important part is that when you define the domain of the sum, product, difference, and quotient, the domain of that sum, or that domain of that difference, the domain of the product, or the domain of the quotient is only going to be the x values that are in the intersection of the original two functions f and g. So for instance, if f of x had a domain of, let's just say, we're going to use the function x squared, and the domain would be negative infinity to infinity, and g of x was 1 over x plus 3, my domain would be negative infinity to negative 3 union negative 3 to infinity. The function, when you either add these functions together or subtract them or multiply them or divide them, is you're only gonna be allowed to use x values that are in the intersection of these two domains. Well, this first function, f of x, has a domain of negative infinity to infinity, which if I draw that on a number line, we would graph that as a number line with the entire thing shaded. And then for the second function, I would draw and shade everything except for negative 3. So if we intersect the domain for f of x and the domain for g of x, which I drew here, the function where you add these, subtract these, multiply them, or divide them, its domain is going to be negative infinity to negative 3 union negative 3 to infinity, because I have to leave out negative 3, since g of x, you could not use negative 3 as input for x. So any function operation that you would do with f of x and g of x, would have to have a domain of negative infinity to negative 3, union negative 3 to infinity, because negative 3 was not an option, a valid input for g of x. In example 1, we're asked to use some operations with functions. It says, given the functions f of x is x squared minus 2x, and g of x equals 3x minus 4, and h of x equals negative 2x squared plus 1, find the function and the domain for f plus g of x. So I think often it is easiest to find the domain first. So if I look at the domain of f of x is going to have a domain of negative infinity to infinity. If you think about the graph of this function, it's a parabola opened upward. It's continuous from left to right if you look at the graph of f of x on your graphing calculator. Or if you look at it, we have no square roots or fraction where we have x in the denominator. So the function should be continuous from negative infinity to infinity. G of x is a straight line, 3x minus 4. Oops, minus 4 is what I meant to say there. That is a straight line. Again, we don't have a square root or an even root or x in the denominator because we have no denominator there other than, I guess you could put a 1 on bottom if you wanted to. Your domain here would be negative infinity to infinity. It's a straight line from left to right that extends infinitely to the right and infinitely to the left. So since both functions have a domain of negative infinity to infinity, the intersection of that would just be negative infinity to infinity. Both domains share all the same x values. So f plus g of x is going to have a domain of negative infinity to infinity. Now, I'm going to go ahead and erase my work for the domain here. A little bit here. If I erase that and give myself some room, I want to go ahead and add the two functions together. Okay, so if I add the two functions together, I'm going to go ahead and add f plus g of x, so that's the same thing as saying f of x plus g of x. And I'm going to go ahead and add f of x together with g of x. So f of x was x squared minus 2x, and I'm going to add that to the function g of x, which was 3x minus 4. Really, I don't need the parentheses here with addition because it doesn't make sense for me to distribute a positive sign there. So I'm just going to drop the parentheses and say x squared minus 2x. This is going to be a plus 3x, and if I add a negative 4, I'm still going to have a minus 4 down there. Now, combining like terms, I'm going to get x squared. Negative 2x plus 3x is just positive 1x. And then I have minus 4 at the end. So f of x plus g of x is equal to x squared plus x minus 4. And that is your function, the sum of f of x plus g of x. And like we said, the domain is going to be negative infinity to positive infinity. In example 1, part B, we're looking at operations with functions. We are still given the same three functions as in part A. We have f of x, g of x, and h of x. This time they would like us to find f minus h of x, and as well as its domain. So I'm going to start with the function f of x, which we already determined in the last example had a domain of negative infinity to infinity. And h of x is also a quadratic. It's going to be a downward parabola. And we know since we don't have any even roots or x in the denominator, our function has a domain of negative infinity to positive infinity. So our function here, f minus h of x, is going to have a domain of, I'm going to write that at the top, negative infinity to positive infinity. And that's the domain of the difference of f and h. Now I have to actually go ahead and find out what the equation is for f minus h of x, which is really just f of x minus h of x. Okay, another way to write f minus h of x is f of x minus h of x. And we're going to take the original function and subtract h of x. X squared minus 2x is f of x. And then I'm going to subtract from that the function h of x, which is negative 2x squared plus 1. And what I need to do in this example is I need to start by distributing this subtraction sign through the parentheses. So I end up with x squared minus 2x plus 2x squared minus 1. And x squared plus 2x squared equals 3x squared. And I still have a minus 2x, no other x terms to combine it with, and then minus 1. And I would then have a function of 3x squared minus 2x minus 1 is the difference function for f minus h of x. And remember, our domain then is negative infinity to infinity. In example 1, part C, we're given the same three functions, f of x, g of x, and h of x. And we are asked to go ahead and find the product of f and g. So what this really means is f of x times g of x. I already know because the domain for f of x was negative infinity to infinity, and also g of x was negative infinity to infinity. You are going to have a domain from negative infinity to infinity. The intersection of these two domains, since the domains are both the same, would be negative infinity to infinity. So my domain is negative infinity to positive infinity, and we're going to take f of x times g of x. And so if I multiply those together, I get x squared minus 2x times 3x minus 4. And I'm going to have to, when I multiply two binomials together, because we have a binomial here and a binomial here, we are going to multiply the first terms together, which gives me 3x cubed. I'm going to multiply my outer terms together, which I'm going to get negative 4x squared. I'm going to multiply my inner terms together to get negative 6x squared. And then negative 2x times negative 4 is positive 8x. So what you're going to do is you're going to add your like terms. Since I have two x squared terms, we're going to combine those to get a final answer of 3x cubed minus 10x squared plus 8x. And that would be my final answer for the product of f times g of x. F times g of x is 3x cubed minus 10x squared plus 8x, and our domain, because both individual domains for f and g were negative infinity to infinity, our domain for the product is also negative infinity to infinity. Example 1, operations with functions. We're looking at given the same functions, f of x, g of x, and h of x, finding the quotient of h and f. The quotient of h and f is h of x over f of x. Looking at these two functions, we do have to do a little bit of work with our domain. Our domain here is not going to be negative infinity to infinity. Because of us dividing the two functions, we know that f of x, since f of x is on bottom, cannot equal 0. So this implies that x squared minus 2x cannot equal 0. Again, because f of x is on bottom and we don't ever want to divide by 0, we substitute x squared minus 2x for f of x. and we state that f of x cannot equal 0. So that's the equation I have written here. I can solve this by factoring. Both terms have a common factor of x here, which leaves me with x minus 2. So I have x times x minus 2 cannot equal 0. And if we use the zero product property, since I'm multiplying these two factors together to get 0, or don't want to equal 0, that's telling me that x cannot equal 0 from this factor. And for this factor, x minus 2 cannot equal 0, which implies that x cannot equal 2. So I know that in my function, the quotient function has a domain of negative infinity to 0, union 0 to 2, union 2 to infinity, because I cannot include 0 or 2. And if I graph that on a number line, we're going to have 0 with an open hole, 2 with an open hole, and then shade everything else on our number line. Okay, so we know that our domain is negative infinity to 0, union 0 to 2, union 2 to infinity. And then our function h of x over f of x can just be written as negative 2x squared plus 1, because that's h of x. Divide that by f of x, which is x squared minus 2x. Some people will probably try to say we can cross out the x squareds, but you cannot cross off this x squared with this x squared because you're subtracting here and you're adding up here. You can only do that if you were multiplying. So if you had something like x squared times x plus 2, I'm just making up another example here, and then you had another x squared on bottom, since you're multiplying x plus 2 times x squared, then you would be able to cancel out the x squareds. But in this problem in particular, since you're adding a 1 to 2x squared on top, or negative 2x squared on top, and you're subtracting 2x on bottom from the x squared, you cannot cancel out the x squareds. So that would be your final answer, negative 2x squared plus 1 divided by x squared minus 2x on bottom. And our domain, of course, is negative infinity to 0, union 0 to 2, union 2 to infinity. It's time for a checkup here, a check for understanding. I want you to find the sum, the difference, the product, and the quotient for the given functions f of x equals x squared plus x, g of x equals x minus 3, and I want you to state the domain of each new function. What I'm going to do is I'm going to give you some time to write this down. Write down f of x and g of x. And I want you to write down what the sum of these two functions are, what the difference is, what the product is, and what the quotient is, as well as the domain of each of those new functions. So you need to tell me what the domain of f plus g of x is, what the domain of f minus g of x is, what the domain of f times g of x is, and the domain of f divided by g of x. And then tell me also what the equations are. So go ahead and write that down, work it out, and I'm going to provide you some answers on the next slide. On this slide are your choices for the check for understanding. You have choice A, B, C, and D. The first function is for the sum. The second function listed is for the difference. The third function would be your product, and the fourth function obviously would be your quotient. And so what you need to do is go ahead and work out the sum, the difference, the product, and the quotient if you haven't already done so, and then find the domain of each of those functions, and then choose either A, B, C, or D as your answer, and press submit when you're done.